go to GNPS UCSD Edu. And here, you can already log in with your account. So I'm just going to do that now. That's incorrect. This. So in the top right corner, you can just type in your Massive and GNPS user credentials and sign in. Don't save. And now here, this is the landing page. If we scroll down, you're going to see that in the top, there's some links to the forum, and there's some links to a quick start guide, and also to the documentation. And I want to highlight that the documentation is pretty extensive. Like you could like go there and read on more. And also, if you find it's not precise enough, or it doesn't explain everything that you struggled with, it's like open source. Like it's a community effort, so you can also contribute and add to the documentation. Similar things is true for MZMine. And if we scroll down further, there's different data analysis workflows. And for this workshop, we focus on the feature-based molecular networking. This was, we did MZMine feature finding. We export the table and one spectrum of MSMS fragmentation information for each feature. And this data, well, this information we want to upload to GNPS now. And I would like to start with the super quick start, because I think it actually is like the easiest way to get started, at least. So you just click on GNPS super quick start interface, not the guide, interface. And if you don't find it, it's also just GNPS quick start dash quick start, and then UCSD edu. And then on the top row, you can see there's multiple different quick starts, and you already see there's like data conversion, some other things that might be useful for you, so you can check it out. But we go for feature-based networking. And so if you click on it, it should be like a subdomain. And if I scroll down, I can select the feature finding tool. It says MZMine 2, but it's actually the same format. So we choose MZMine here. And there's 4 drop-down boxes. So we have required files. On the left side, you can see feature quantification file or table, file required. And if I just shift this to the side here and open the results, sorry. Yeah. So getting to this one, you just go on GNPS-quickstart.ucsd.edu, and then you can click on, in the top row, feature-based networking. Make sure to click on feature-based networking. It's a subdomain, so you should see it in your URL. And then scrolling down, we select MZMine 2. It's also the default. Then we have the feature quantification table. And we actually got the feature quantification table here. It always ends with a quant.csv. Yeah, so I gave it a name, GNPS, FBMN, lab 15, and so on, quant.csv. So it always has to be a CSV file. And I'm just drag and dropping the file in here. Or you can click on this box and it's just going to open a file explorer and you can just select it there. So the only CSV file that we resulted with, that's the one. And then the second file that we select is the MGF. And you can already see there's also some other files that are supported, but MZMine provides you with an MGF. But now we have to be careful. We actually exported 2 MGFs. And this is sometimes a bit confusing why we do this. It's because it's a very similar format, actually, very similar data, but GNPS and Sirius are different tools. So GNPS uses the MS2 data, and Sirius actually uses all MS2 spectra and all MS1 spectra that we export. So for all the features, we actually export more information for series. And also GNPS only uses one MS2. So it's like one merged MS2 or just the most intense. Either way you select it. And for series, we actually export everything and they like downstream merge the spectra and so on. So I use the GNPS FBMN, MGF, and I drag and drop it into the second file, in the second box here. And then yeah. And yeah, can I? Okay. Yeah, I just wanted to show that you should have actually. Okay. What? No. Oh my God, they actually changed so much. Okay, so, and you should in your folder and on massive, you should actually find the metadata file. So it's, yeah. Oh my God. Okay. Okay, so yeah, it's here. Okay, so yeah, you should find on the massive data files, you should find the metadata text files, and so you can just like copy this over as well to your machine, and then once done, we go back to the submission. Here, we go back to the submission, and you're going to find the metadata file as the third optional file that you can submit. And for me, of course, it's lab 15. So I'm going to drag and drop the file here, and it's done. So we uploaded the quantification table. We uploaded the spectral files and metadata. Metadata is used later on so that we group files together so that we can do statistical analysis and visualization on the networks that we produce with GNPS. The one that's not full. Okay, so at least with the batch that we, yeah. So with the batch that I shared with everyone, we only exported like a simple feature table where we only had like very limited information. Some people that did it manually, maybe you have a file that also says CSV, but then quant full. Don't use this file. Like it's very complex. It's if you're like going deep into features and you want to look at more information, you can use it, but you shouldn't have exported it, at least for this batch. So just a quant CSV. And from here, so I have all three selected. I can, again, just give my user credentials. And I think also this is a nice thing, like the quick start actually doesn't need you to have a user account. So you could do it as like an anonymous user just to try it out. But because I want to have this job in my job list, I'm actually going to submit with my username and with my password, and then click on Analyze with Feature-Based Molecular Networking. And also, if you want, you can give an email address and then get notified once the job is done. Yeah, I'm just going to do that as well here, just to be complete. Oh, German. Depends very much on your data. Depends very much on the load that's currently on like the GNPS servers. But it can range from like minutes to maybe like an hour, maybe 2 hours if there's like a lot of load currently going on. Or of course, if something goes wrong and it has to get like rescheduled. But usually it's, I would say like 10 minutes, 20 minutes, 1 hour. Sorry? Wait, what? Okay, so I click on upload and analyze. And here we get to the job page. And this is actually quite cool. Like you can already save this link and you can send it to any collaborator. You can put it in publications. So you can like just put this link and everyone who has the link can access it. If they don't have the link, they can't access. I mean, they have to find out the hash, right? But so you can just put it in your publication and so on. And it's a very nice way, once it's done, that people can like find your data, find your results, download the networks, find what kind of compounds you identified, and then like work with that. And typically the website just updates like regularly, and you're going to see this progress graph, and it's just like a very rough estimate of like how far it's already gone. And you can also see that there's like, it's a whole workflow which combines multiple steps, and it combines library matching, networking, and a bunch of other things, and we'll end up with the feature-based molecular networks that we know from online. And also, you can already make sure that you selected the correct files. So here we see what files were selected. We have the MS2 file, should be an MGF. We have the quantification table, which is a CSV, like quant CSV, and we have the metadata. And if someone like forgot to put the metadata here, it doesn't matter. You can later just click on clone and change some of the parameters and also customize it to your needs, and add the metadata file there. So, Danny, what do you think? We should do that tomorrow then, right?
Yeah.
Share the results and what you prefer, but I think the job should be fine.
Yeah, that's great. So yeah, first of all, thanks. Maybe a couple of more words to the quality checks of the feature file. As again, one is track out. This is really essential for all your downstream analysis. So be critical with like the results you get out of it, and don't assume that whatever file there is now that's the proof, right? So particularly, I've seen like while going through like talking to some of you that sometimes the feature numbers, so basically like the rows of features in like the CSV file might have been much less or much more than like what Robin produced. So there, like, being like aware of the complexity of your sample and thinking about, okay, is that a realistic number of like features I got here? That could be like a first type of like quality check. So who of you got more than 2,000 features?
So to check that, you can right click on the feature list and then feature list summary, and you can just go with the latest aligned feature list and get this number.
Okay, can I see the hands again? And who had less than 2,000 features? Oh, 2 people have less. So yeah, that could be an indicator that perhaps like, because those samples were the same, right? And like, I think all of the instruments that made it into that data set kind of performed well. But that could be simply due to the fact that the threshold was like a little bit too high, what you've set there. So they may be rerunning it with a lower threshold, might bring up that feature. Who had way more than 5,000? Okay, interesting. Who had more than 10,000? So maybe you're like on the upper end, and maybe your threshold was like a little bit too low.
I saw like one person had like 50,000 on a single feature list, and the alignment didn't work out. But this was fixed like once we went into the batch mode and we saw that just one parameter was just not 5E5, but just 5. So sometimes it's like easy things like that, right? But sometimes because we have different data sets, we don't expect it to be the same, right? So that's the idea of this.
So yeah, on that note, like in addition to feature-based molecular networking, so this is where kind of like all this kind of like leads up to. What I typically recommend people, especially if they're starting, is to also just run a classic molecular networking job. And that has something to do with like, checking, okay, what MSMs are in there and what compounds do I ID by only looking at the MSMs without any chromatography, deconvolution and whatsoever. Because then you see, okay, I don't know, there's like, let's say 300 compounds identified, and now if you like only ID, let's say 15 in your feature-based molecular network, then maybe something was not ideal with like the settings here. So typically, if that is done well, I would expect you to have more IDs than with like the classic molecular networking job, because we deconvolute isobars, right? So like there should be like way more features than just by like the cluster MSA. So I think, yeah, that's important to keep in mind, not only now for the project work here, but especially when you like go back to work on your own data. So yeah, I think if you have doubts, again, like we're here all week, right? We can chat about the particular jobs you run, or perhaps about your own data. And yeah, I guess by the end we get like kind of like good idea of how to proceed with that.
Yeah.
I think for the like MZ Mine session, unless there are like some questions from you, I think that's all we wanted to get you to. So basically to submit the feature-based molecular networking job, and then tomorrow morning Allegra is actually going to walk you through and show what now in GNPS under the hood is actually happening with like this data that we just like submitted there. Okay, I guess I don't know if there's questions for Robin and Stefan. Feel free to ask.
Yeah, we did not suppress the blank. Is it possible to do it? Yes, we do have something that if you also run the feature detection on your blank samples, that you can subtract them. So subtract the features that were detected in the blank from everything else. The question is, I'm not an expert in statistical analysis. What's like the best thing to do there to keep them? So you can like, because if you remove it, you have no information on like the blank features whatsoever. So I think for statistical evaluation afterwards, it might be better to keep it in there and just cross everything together. But there is the option, yes.
Yeah. And we're also gonna go like look at that like downstream. It's usually easier than. And I just want to highlight, it was very confusing and many people struggle with this part here, but there's also like some, I mean, we're going to put this confusing workshop like online, but there's also some other workshops where, we did like in a different way, explain the same thing. And I think it's good to like get there from different angles. And overall, like I think the CMFI mass spec seminar that Daniel was like doing online, inviting like so many different people, work on like speak on different topics is very nice. Like I heard from many students who were just starting out with it, that this really helped them, like just go through like the tools and learn, because it's just like 1 hour or less, and then like everything in there. Yeah.
Yeah, I think kind of similar to the blank question. So what I would usually do, or what I think is customer quality or control, is that I have full QCs and I only use those features that seem to have like low technical variation. So there's some way to pick out some features that you do not want to process because they are supposed to have like the same intensity of each area throughout all the QCs.
That's usually so. The question was if like we could also use pooled QCs, because many people use pooled QCs, so just pooling all the samples and then basically measuring it over and over again. And you should not see like a huge deviation across the QC injections. I know that some people love the pooled QCs. and they are good for like specific things. But then because you also dilute your samples, so if you're looking at samples that are very similar and you want to see features that are present in most of the samples, you're going to detect them in the QC. If you have some compounds that are very specific to a subgroup of your sample set, you're going to dilute them down and they're going to fall out because like they fall out the analysis because they're going to have more than 20% of variation, or they're just not going to be in the QC, right? So you don't have a variance on those features. So it's a very nice example, and many people actually do both, right? Pooled QCs and then just like standards mixed up to QC. So it's like very hard. We usually do it downstream in like R and Python and like all the other tools. Yeah, it's a bit more flexible because people want to customize it, and so yeah. Yeah, okay, that's it. So definitely highly recommend this, and I guess we're going to put it out later as some more resources. And gonna finally give over the stage to Axel. So